And how perfect is it to do powders on a day where there is powder coming out of the sky? It was just meant to be. Alright, so let's do it. Alright, so, and I will try to do this as quickly as I can, but there's some background stuff we need to do. You're going to be doing some powders to understand why the compounding goals and everything else. Make sure you understand the definition of powders are intimate mixtures. And that's easy to remember after Valentine's Day. So remember, powders need to get together very closely. They need to be intimately mixed. We'll talk about how you're going to do that. They are dry, finely divided. Part of what you're going to be doing today as your procedure is to make sure they are finely divided, so forth. And they are chemicals or drugs intended for, and this is kind of important for labeling, internal or external use. So a powder can be applied either way. Okay. So today, what is your wet lab? What are you going to be compounding? We are doing what form of powder? Internal or external? External. You're making a topical dusting powder. So applying drugs exterior to the skin topically. Do you hardly ever compound powders for internal use? Well, what is your next dosage form? A capsule. What's inside the capsule? A powder for internal use. So you're just encapsulating it. So powders are obviously used for both internal and external, and that's why it's very important to make sure whatever your product is labeled such that we know that it's intended for external use. Okay? All right, enough said with that. As I said, to make sure we reach that definition, things that you're going to be doing today to ensure a good quality product. And we will be looking at your product and making sure it's adequate in terms of its formulation. We are going to make sure it is uniform, finely divided. Okay, how are we going to make sure that it's finely divided particles? What is the technique you'll be using? Trituration. I know it's on the slide, but what are you going to be using to do that? Your mortar and pestle, and that's the grinding motion. You're not just pushing and blending, you are grinding that stuff down to reduce the particle size. Okay? Homogeneously blended. So for today, you're going to be putting your powder in a shaker bottle, and you're going to be shaking this powder out. That powder contains 4 different ingredients. Every shake has to have the same concentration of all 4 of those ingredients. How are you going to make sure that your powder is homogeneously blended? How are you going to make sure a little bit of one ingredient with a lot of another ingredient and so forth? How do you make sure they're all evenly dispersed? Geometric dilution. You're going to have to mix them in a way that as you do your trituration, that you're dispersing and making sure that all of the ingredients get evenly dispersed on that. So that geometric dilution is very important for that. And lastly, it does need to be free-flowing. You'll see today that your powder at first is very clumpy and pasty, and it would no way shake out of a shaker bottle. That in itself would not be good. But your final formulation is such that it does shake out of the shaker bottle. It is free-flowing enough that it would spread on the skin and be able to be applied. So again, we want to make sure your final product does meet those kind of compounding goals. Right? Lastly, and very important, every dosage form you're going to do for us, so hopefully you realize from the very first week. Remember when you guys were mixing some of the powder for the first time in that mortar, did some of it get on the sides of the counter and on your gloves and everywhere else? So there is loss, okay? You're going to go to a lot of work to prepare something for a doctor. You want to make sure you have enough to dispense based off what the doctor prescribes. So we're always, maybe the amounts will vary, but you will always compound for excess, but only dispense the prescribed amount. Are you clear on that? I want to make sure you understand. Your calculations and your formulation is going to be for more than what the doctor has prescribed for, because as you do that, some of it will just disappear. So that in the end, though, you have enough to be able to dispense the prescribed amount. If you're awesome and don't lose anything, can you dispense all of that excess? No. Remember, you're only authorized to dispense the prescribed amount, but you're going to compound and therefore probably have some excess amount of product. That doesn't mean you can dispense it all. So don't get those two things confused. For today, all of our calculations for powders, topical powders, we want you to base everything off of the preparation of 10% excess. If you calculate everything for 10% excess, then when you lose some of that powder on everything, you'll still have enough to be able to dispense the prescribed amount. So keep that in mind. All right. These are the steps that we're going to go through as the prescription, as we compound the prescription here. And I want you to realize it isn't just going making the thing. It's all of these steps. From the very first thing, like any other prescription, you're going to read and interpret it. You'll see it with our dry lab. It's very important. If you don't interpret it correctly, you're going to make it wrong because your calculations are going to be wrong. So reading and interpreting and really understanding, A, what it is that they want and why they want it to make sure it's appropriate is still important. Once you've done that, though, you're going to look on the right-hand side and look at that additional information. There's sometimes very important information there. So given that additional information on what's being prescribed, do you understand what's being asked for? Okay? That's the time you complete the formulation record as well. Okay? Then you go over to the shelves and look to see what are my actual chemicals. Do you remember the very first week? Sometimes your active agent can come from what? A bulk powder, or a tablet, or a capsule. Does that make sense? You got to know what am I using to make this product. So that's where reviewing the ingredients is very important. Once you know all that, that's the time you can start on your calculations, because you can start thinking how you're going to formulate it. So you do your calculations, you double check your calculations, and if they're right, then you go and you make the product. Okay, and then don't forget, even after making it, you're going to be documenting the procedure. Today in the learning labs, we give you the typed up procedure, so you don't have to write it all out. But on the exam, the procedure is what? Blank. You will be writing the procedure. So remember, as you compound, you will need to be writing out the procedures so that you can document your steps. And then lastly, all of the other documentation. So let's just get to it, but that's an important idea to keep in mind, that we're going to be doing all of those steps as we progress. So, does everyone have the dry lab up? Everyone have this prescription for Rose Bontrager? It's the dry lab, where this is the one we're going to do together. Unlike the first week, you're not going to replicate it outside. We're just doing this together in here. The prescription you're working on your own out there is going to be different, so it's not the same prescription. So we're doing this one together. So let's read and interpret it. It's for Rose Bontrager, who is an infant, and the doctor has prescribed, let's see here, ZNO. What does that stand for? Zinc oxide, so zinc oxide, talc, cornstarch, and calcium carbonate. So 4 ingredients there. This is what I mean by the interpretation. Make sure you can get this right. It says AAQS 20 grams. So does that mean, AA means of each, so we're going to use 20 grams of zinc oxide and 20 grams of talc and 20 grams of cornstarch with 20 grams of calcium carbonate. We're using 20 grams of each of those, right? Is that the correct interpretation? It is not. You see what I'm saying? What did I leave out there? The QS. It says of each QS up to a total of 20 grams. So it basically means use even amounts of all 4 ingredients up to a total of 20 grams. Okay, so we're going to combine those 4 ingredients, make a base powder that has a total weight of 20 grams with all 4 of those, and to that we're going to add nystatin that comes commercially as 100,000 units per gram powder, so we have that powder. We're going to dilute that or mix that 1 to 10 with those base powders. All right, a little bit of math. You remember doing some cereal or doing dilutions? We got some dilutions here. We got some basic math stuff, not overly complicated, but it's a good review, and that's why we kind of want to get you back up to speed before you hit rotations, which you, congratulations, all know about. So fantastic. All right. Any questions about that? Now, what are we making? What's the point of this? Remember, we still got to make sure it seems reasonable. It's a powder. What kind of powder? She's an infant. It's a diaper rash powder. Does this make sense? Would this be something you'd want to make? So let's go down below and start filling out the formulation record. You can start writing that out yourself if you want. But let's think about this. What are those ingredients? So nystatin, you know what nystatin is. What is nystatin? It's an antifungal, right? Does that make sense for a diaper rash powder? Absolutely. The diaper rash, diaper is going to hold the moisture in there, and it cause irritation, could promote fungal infection, so an antifungal would work really well for that. Zinc oxide. What kind of drug is that? Have you ever seen the lifeguards with the white noses where they put that big white cream on their nose? That's zinc oxide paste. That's basically a protectant. It doesn't let any sunlight through, and it keeps them from burning their nose. Same thing on for the baby. It'll be a protectant. It'll form kind of a barrier between the baby's skin and the liquid contents of the diaper. So it's also a little bit of an antiseptic, which is helpful. Then the other 3 ingredients, the talc, the cornstarch, and the calcium carbonate, are powders. But we're making a combination of powders, and what's special about their property, and I know it's kind of listed up there, but they're very what? Absorptive. They're drying powders. They can absorb and hold on to water and moisture, and will keep that moisture obviously from contacting the baby's skin and causing irritation. So we have a lot of powder to be able to soak up and dry up moisture, antifungal to try to keep any infection from going. Sound like a pretty good diaper cream, or not cream, but a powder to you? Seems like it would match with what we're trying to accomplish, so I think that sounds pretty good. Now, the term and the purpose between active and vehicle on this is a little bit vague. Clearly, the antifungal, and I think the zinc oxide could be classified as active. The other drugs have an important role. The drying role is very important here for this cream, but I do have them as a vehicle to essentially kind of dilute the other active ingredients. That's what a formulation record is. It's you making sure you understand what the purpose of this compound is and that it makes sense. Okay? Any questions about that? Last thing on here, I said to always look at the additional information. This doesn't have a lot there, but it does remind you, before we go forward, that we're going to base our calculations on 10% excess. But I want to remind you here, I will not remind you about that on the exam. Does that mean on the exam you shouldn't do it? No, it means that I don't want to have to remind you. You should now know that for powders, topical powders, when you formulate them, you want to base your calculations on 10% excess. I will not remind you of that for the exam. It's still something I would expect that you do. Okay? So far so good? All right, let's look at the ingredient list. So scroll down or go to the next page. Let's look. I mean, we kind of know what we want to make. What are our sources of all of those active ingredients? So I will, on the dry labs, always give you these. Now, on the wet lab, you're going to have to go write down the manufacturer, the lot, and the expiration off the actual bottles. For now, I've gone ahead and give you those for the dry lab. But let's look at the ingredients. Zinc oxide powder USP. What does the USP stand for in an ingredient list like that? It specifies the quality and purity of that ingredient. So that's a bulk powder. USPs are almost always bulk powder. So again, zinc oxide is a pure powder, talc's a pure powder, cornstarch is a pure powder, calcium carbonate's a pure powder. So those are pretty easy. Those are just bulk powders of each of those ingredients. The only thing that's just a little different is the nystatin. It is still a powder, but it comes in a concentration of 100,000 units per gram. So again, all we got to do is mix 5 powders together and we're golden, right? Not a difficult compound to make. We just got to make sure we get the right amounts mixed together. While we are here, though, let's go ahead and take a time to go ahead and determine our beyond use date. All right? So what I always like to do is where we got this drug list here, let's go through and circle the ingredient with the shortest expiration date. So the commercial products, which of those has the shortest expiration date? Let's circle that. Okay. So 9 of 2019. Okay, let's just be clear on that. Well, further. So what is today's month? 2 of 2019. So how many months from now is that? 9 minus 2 is 7 months. Would you agree that makes 7 months from now? So is our beyond use 7 months? Well, USP 795 says it's the shortest expiration date of any ingredient, or for powders, what does it say for or? 6 months, 180 days or 6 months. So you can never, for a powder, apply more than 6 month expiration date. So even though our shortest ingredient is 7 months, we're going to have to put a 6 month expiration date on it for our product. On your documentation, you need to make sure that you include both the month and the day and the year. So for what is your BUD, what would it be? Would it be 6 months on to today? What, 6 plus 2 would be 8? 8/15 of 2019. Okay, 8/15 of 2019. Is that 6 months from today? That's what we would assign to the beyond use date. Okay? Any questions with that? All right, so now we know our ingredients. We got that. Let's start doing our calculations here. So this is where you definitely want to pull out the same calculator you're going to use for me on my exams. The whole point of the learning labs is to practice and to make sure you do well on the exam. So if you've got the calculator you'd probably use on my compounding exam, get that one out so that you can practice on this. As you're doing that, I'll also remind you that on the learning weeks, I give you some guided examples of what to do. I'm going to walk you through the calculations on this. On the exam, the calculation section will be blank. I will not tell you what calculations to do. It's your job to figure out how to formulate it. It should be just like what we do in lab, but it's still your job to kind of know how to approach these calculations. But here, we're ready to teach you. So with that, let's get started. The first one says, determine the required amounts of the zinc oxide, talc, cornstarch, and calcium carbonate. Because we knew that we were going to have all 4 of those QSing up to 20 grams, right? So obviously 20 grams divided by the 4 ingredients would equal 5 grams per ingredient. Would you agree with that? Stop. First of all, don't ever trust me. For 2 reasons. A, I screw up. So if I make a math error, please correct me on that. Secondly, it's not right. I've already made a mistake. Because I didn't account for doing what? Calculating for excess. So while it says 20 grams to dispense, we need to calculate for how much excess? 10%. So actually erase that. That's not where we're going to start. We need to start with the fact that while we know the doctor prescribed 20 grams for those powders, we need to increase that by 10%. So multiply that by 110%, or 1.1, however you want to do it, and tell me how much we really are going to need to compound. 22 grams. So that's the weight of the 4 powders. Would you agree? To have 10% excess, we need to formulate it for 22 grams. So take 22 divided by the 4 and tell me what that equals. You get 5.5. This is what I'll try not to say my answer quite so quick. I really do want you to do the math yourself. This math isn't hard, but I want to make sure you understand the procedures to go through that. Easy breezy. 4 out of the 5 calculations are done. We need 5.5 grams of each of those 4 base powders. All right. So let's move on to the required amount of nystatin. Okay. So to do that, it's a little more difficult. Okay. So bear with me. I don't know if I got the best way to explain this, but we're going to have to set up some proportions. Okay. Because we know we want to dilute our nystatin excuse me, 1 to 10. Do you agree? That's what we said. Mix 1 to 10 with those base powders. So I'm going to, on top here, I'm going to write 1 gram of nystatin on the top left. So on the top, I'm going to put 1 gram of nystatin over something is equal to some amount of nystatin I don't know. So I don't know the amount of nystatin to use. What's the only thing I do know? What did we just calculate for? The 22 grams of powder. Would you agree? I do know that I need 22 grams of powder. So if we're going to mix nystatin, 1 part of nystatin to 10 parts of total mixture, what is the total mixture in this case composed of? Nystatin plus powder. Are you with me on that? If we just group all those together, the 10 parts represent 2 things, right? Nystatin and powder. So if I've got 1 part nystatin on top, and I know the amount of powder I need is 22 grams of powder, then how many parts of powder is that going to be? 9. Okay? I need 1 part of nystatin over 9 parts of powder would equal some unknown amount of nystatin over the amount of powder I'm going to use. I'm going to be using 22 grams. Okay? This is kind of a dilution calculation. Does this ring a bell a little bit, where you have to subtract 1 from the base number, because the base number, the 1 to 10, represents the combination of both, okay, the nystatin and the powder. So in this case, we know 22 grams of powder. That's therefore only going to represent 9 parts, because the 10th part is the nystatin in the mixture. So nystatin 1 part over 9 parts of the powder is equal to X amount of nystatin over 22. So solve for X. Basically, what is 22 divided by 9? Can somebody tell me that number? And calculate that. And I got to put it below the line here. 2.44 grams. That's what I got. Any questions on that? Because there may very well be a dilution type, that kind of thing on the exam. Please talk to Judy or I outside of lab. I know that can be a little bit tricky for some people, but that's how we came up with it. Okay. So we now know all of our ingredients. We can make this right now. I need 2.44 grams of nystatin, 5.55 grams of everything else. Just mix it. We'll talk about how to mix it. That's it. The last thing, though, we got to do calculation-wise, though, is part of what you always have to do on every exam is type the prescription label for the drug. It's just the drug name that would be on the prescription label. You have to know how to label these compounds. All right. So for an example, how do we label the active ingredients in a topical powder? How do we express their amounts? Not by weight, but we express it as percent weight per weight. Okay, so we need to be able to say for all of our ingredients, what is their activity or the amount there by percent weight per weight. So let's just do that for the 4 drugs or for the 4 base powders. Not hard. How much drug, how much base powder individually is in each one? We're going to weigh out how much? 5.5 grams. And just simply divide that by the total weight. But what will the total weight be? It'll be the 2.44 grams from the nystatin plus the 22. Okay. So remember to divide it by the total weight of the product. So we're going to have 5.5 of each individual ingredient divided by the combined of the nystatin and the powder, the 2.44 plus the 22. And what did you get? Mm-hmm.
Why are we doing 1 gram of nystatin to 9 grams of powder?
Okay. Because when I say powder, let me make sure I'm referring to just the 4 powders themselves. Okay, just those 4 that we combined together. Mm-hmm. What it wanted to do is to mix a total of it wanted to dilute 1 part or do 1 part of nystatin to 10 parts total mixture. So you're going to make the powder with the absorbent thing. So you want to dilute it 1 to 10. Yeah. So 1 to 10 dilution with the absorbent powders. The 1 part of nystatin is to 10 parts of the total final mixture, not just with the absorbent powders. Let's talk about it afterwards. This is tricky, and I don't know that I set it up great. I can try to kind of set it up a little more differently if you're still having confusion on that. But you normally, when you do dilutions 1 to 10, you subtract 1 from the base when you're comparing it to just one of the other ingredients. Okay. So, anyways, a good question. 22.5%. Is that what you guys got for the percent for each active ingredient, except for the nystatin, right? So nystatin is expressed in units, so we're going to have to do it differently than a percent. So let's do it for the nystatin, and so again, that's that one there. So let's do 2.44 grams, right? Times, what is the concentration of the nystatin? 100,000 units per gram. When you do that, you should get a total of 244,000 units. And just divide that, right? That's the total amount of nystatin we're going to have in there. And what will the total weight be? Again, adding the two together, it's the 24.44 grams. If you do that, you'll get the total in the units will be in units per gram. So 244,000 divided by the 24.44. I got 99.84. Everyone okay with that? Got it? I like this class. You got to pull out your calculators. I like calculations. All right. Now, last thing is you're going to make all that. So we're going to weigh all that. We're going to make it all. But can we dispense it all? No. So in the end, we still need to know what the actual amount we're supposed to target for our dispensing amount. So the easiest way to do that would be to take because we did 10% excess, right? So what I would do is just take the 24.44 that we know is going to be our total with the excess times 0.9, right? That would give us essentially 90% of that would be reduced by 10%. So what is 24.44 times 0.9? I got 22 grams. Okay. So what was the point of the 22 grams? Does everyone okay where the 24.44 comes from? 2.44 from the nystatin plus the 22 from the powders. All of that together is 24.44. And we did that so that if we spill some stuff and we lose some stuff, we still got plenty. But that still doesn't tell us exactly how much we are trying to dispense. And part of what you're going to write down here in a little bit is your final QA, the amount going to the patient. What the doctor has authorized to be prescribed essentially exactly is 22 grams. So we're going to try to weigh to a target of 22 grams, discard any excess that we may have formulated just to make sure we could get the 22 grams. Okay? So that's kind of where all that comes from. Now, before we go any further, I need you to go back to here or I say back to here, look on your compounding record and look under the target amounts. The reason for doing these calculations were so that you now have the targets for what Judy is going to weigh up here. So it's very important that you write down those calculated values for each ingredient in the target weight. So for each of these, we'll write down for zinc oxide, what was it? 5.5. Make sure you include units, grams. 5.5 grams. 5.5 grams. And 2.44 grams. Now, what's really important here is Judy in a minute is actually going to weigh these. You need to write down, and we will be checking on checkout the fact that you did all this documentation, you need to write down her actual weights, because now, while that's our target, that may not be our actual. So now Judy is going to go through the procedure, and let's actually compound this. All right, so I messed this up here. Give me a second. I have this all set up too.
All right, so while you guys writing down numbers, I measured my first product. The first one is cornstarch. The actual weight is 5.495. Okay, and pay attention to my label. I says cornstarch there. For me, I'm a single person use a whole bottle, right? But you guys need a what? Cornstarch initial, cornstarch final, because you need to get from the dispensing area first. Okay, the next powder I'm measuring is calcium carbonate. I tared with a weigh boat, but because the weigh boats have different weight, so I have to tare again. Also, I have only one scooper, and you guys have as well, so you never want to dip a dirty one into a different chemical bottle. All right, so clean it, and then measure again. What is my target weight? 5.5.
For calcium carbonate, write down 5.512 for actual. 5.512 actual calcium carbonate.
Okay, next one is talc. Again, make sure you tear between weigh boats and clean your scoopler. Okay.
So talc is 5.511. Talc is 5.511. One more of the absorbent powders to go.
Okay, one more, and the last one is zinc oxide. Here. Perfect.
So for zinc oxide, 5.501. That's okay. 5.501.
All right, we're close. Just need one more nice adding. All right, here.
What's your target now?
What is my target weight?
She's doing that. I will remind you, you guys are going to be going out there with a weigh boat and getting a certain amount of the stock container and then going back and weighing at your station. If you do find that you've taken way more than you need, please return, and it's labeled. I would appreciate if you would return the excess to the stock so I don't waste quite so much money. Any extra that those not that much or significant, you can just discard in those blue trash cans by the microwaves in the powder trash. All right, nice adding. 2.411. I'm sorry, 2.442. 2.442. Good.
Okay, so we have 5 bulk powders. All right, and then we're gonna do something called a geometric dilution. What should I do? So there are essentially multiple ways of mixing them together, right? One of the way that you probably can think of is put that nice adding there and do geometric dilution. Another way is we're gonna actually combine all those absorbent powder together first, then mix with your active ingredient, nice adding in this case. Okay, so we are going to combine those 4 together. And does it really matter which one going first? Yeah, it's all the same weight, so it doesn't quite matter. I mean, just randomly take 2. Okay. All right. One little trick I want to teach you is today you will see in your lab have a lot of drug accumulated over here on your rubber spatula. So rather than just lay on the bench, you probably want to set it on the weigh boat. So therefore, you don't lose any drug.
So how will we know when they're evenly mixed? Were they both white to begin with, as far as the powder goes? So you're not going to be able to use color. The only way you can help ensure that is to geometrically combine. So you just start with even weights and do a good job of mixing and scraping down and mixing and do the best that you can. But that's why the geometric is important, because it's impossible to know for sure when they're completely mixed.
Okay. Can I have the second powder go in as well? I could. Remember, it's equal amount, right? So I have double amount there. I can add both of them together. All right.
When you can see we've got all 4 of them in there. I will warn some of you that want to get a lab, kind of take your mortar and do the blender thing. Okay, remember, keep them in. Don't let it fly out everywhere. You do need to be careful, especially when you're getting a large amount of powder in there, that the powder doesn't come flying out of there with a too aggressive mixing or triturating.
Okay.
Now, can we just geometrically add the nystatin at this point? No, that's not going to work. So what we've done, though, since we've made a nice homogeneous blend with our powders, we will transfer that into a weigh boat.
Transfer all the absorbent powder into a weigh boat.
We need to wash it out. Well, we don't want any water in there, but we'll scoop it as much as we can.
That is aside.
Nice bit next to it. And that's why, I mean, you can just tell there's no way to make sure that the nystatin gets completely mixed in if you try to mix both of those groups together at one time. There's just way too much of the bulk powder. So
Which one you want to go in first? Definitely nystatin, right? Okay. All right. So now you're going to roughly estimate about 1-to-1 ratio. Okay. I'm probably going to add a little bit more than I'm supposed to save everybody a couple minutes.
And now, what's the advantage of the nystatin powder?
It's colors. Is that well mixed? Not quite.
So use the color change. And yours today, even your wet lab, has a grayish color that will change over time. So you can use the color to kind of help you know when you're thoroughly mixed before you can add your next addition.
Okay, so again, I'm probably going to add a little bit more than what I should have. But you guys need to take your time, do your geometric dilution.
We watched Judy do this, which is very fascinating. Let's look on step 4 of your procedure, though. There is something I want to make sure, because everyone will lose some points during the semester with step 4, because this step is the same for all of the different dosage forms. It will say to transfer a certain amount of the product into a certain container. There are 3 things in that line that I will take off points for if they're missing. It says to transfer blank amount. You see where it says 22 grams? Circle that. You have to be specific. You have to tell me exactly. You cannot just say transfer product. I need to know transfer how much. In this case, 22 grams of product. 2, and it then has a size of the shaker bottle and the actual dosage or the closure container system. So the the 2 ounce, in this case, put in a 2 ounce shaker bottle. You'll see do that here in a minute. But it's the 22 grams part, and the 2 ounce part, and the shaker bottle part. It's transfer this amount of product to this size container. So regardless of the dosage form, that last kind of line step there is going to have 3 parts to it. You need to make sure have completely been filled out.
Okay, so we are ready to transfer. Then we will be ready to dispense, right? You don't want to dispense a patient in a bowl like this. So we're going to use a shaker bottle.
Are you going to do that?
Oh, yeah. All right, so make sure that you tear with your shaker bottle, because I don't want the weight of the bottle, but the weight of the powder. So tear with the bottle. And some students ask, does it matter? You tear with the lid on or without the lid? It doesn't really matter, as long as it's consistent. If you tear without the lid, you measure without the lid. If you tear with the lid, you measure with the lid. Does that make sense? All right, so I tear with my bottle, and I'm going to show you the proper way of transferring first. And then I will do a little magic TV show. Okay, all right, so I want to have a little weigh boat, bigger weigh boat underneath my bottle, because I may have a little spill here there. I don't want to lose any powder. I don't know whether I would have enough in the end or not. So you use your scoopler and do a slow transfer 1 by 1. All right, really take your time, okay? Now, I am running out of time, so what I'm going to do here is probably not the proper way that you should have learned.
Good as Judy is, you see powder going everywhere a little bit. That's why the weigh boat's there regardless, even if you do it carefully. Clearly, this is where loss would come in if you're not careful. So we want you to take your time a little more. Yeah? Yeah, you can do all sorts of things that you can do that. In this case, we don't have weigh paper for you in general in your drawers. If you're skilled with that and can do it without making a mess, yes, you can. And you don't have to be paper funnels. There are plastic funnels. There's a lot of powder funnels that pharmacists will use to do that. You have to clean it and make sure that do it between stuff. But yes, funnels work well for this.
Okay, all right. I'm not sure whether I have enough powder or not. How do I know? I have to check that out. So I want to clean my bottle, make sure it's clean. And let's see. Wow, do I have enough?
So what's the but does she have too much? Remember, we can't overdo that. So I'll do this here real quick so I can remember the time. What is 22 times 1.05, right? That would be the maximum she could have would be 20, what'd you get, 3.1? So we don't want to go over 23.1.
I'm happy with that.
Good. Now, are you happy with that? Do we need to write that down somewhere? Yes, that number needs to be written down in the QA section. To the right of the compounding record with all your ingredients under QA, you'll see the top line says final product weight or volume. So extremely important to document what's being dispensed to the patient is exactly 22.432 grams. All right?
Okay, but that's not it yet. You cannot just give the bottle to patient. You have to close with a lid, and this lid you have to kind of press down with your thumbs. You should hear a click. That's not, yes. Okay, so now you can turn, oh, actually, but it's not quite there yet.
Does take some force and kind of a snapping thing. You can use your palms, but I will warn some of you Hercules out there. Some people just mash it down really hard. You will crush the neck of the bottle. So we want to snap the lid on there, but don't push it down so hard that you crush the neck of the bottle, please.
Okay, great. So if you turn the lid, you can see the shaking hole there. And remember, I had a little bit more than I need, right? Because I want to test out before I dispense to my patient. That look really nice. I'm happy with my product. All right. Thank you, guys.
All right. So now let's finish up the QA. Did you write down that weight? The other part to the QA is a description, a physical description of the physical product. So give me a color. What color is that? I know it's not easy to see perfectly up there. Remember how that nightstand was kind of yellow to begin with? So it's a kind of a faint light yellow. So under there, let's write light yellow. Okay, so the first part of the description is the color, light yellow. Then what I need to do is this, watch, okay. I don't smell anything. How would you describe that? Odorless, odorless. Okay, I say this because you guys realize in your wet lab that you're going to do over there, it smells. Do you know what ingredients you're using that smells all by itself? Camphor. And you're actually adding another ingredient to kind of mitigate that smell a little bit. So on your final product, you're definitely going to need to describe the odor or the scent of your product. This one, on the other hand, is odorless. Okay, so we have light yellow, odorless, particle size. How would you describe the particle size? Is it coarse? Is it granular? That would not be a good final product, right? What did you do to make sure that your texture in the very end is fine? So I would call that a fine, meaning a small particle size, so describe it as a fine. And then free-flowing powder. And it needs to be free, and just use that term, free-flowing powder. So this is a light yellow, odorless, fine, free-flowing powder. Why free-flowing? Because coming out of that shaker bottle, did it shake out when she shook it? But remember, if yours, especially when you start initially, it's clumpy. If it's damp or clumpy, it's not going to spread on the skin. It wouldn't come out of the shaker bottle. That would not be a good product. Ours is a free-flowing powder that can shake easily out of its container. So that's a good product. So we want to describe it that way. Okay? Yeah?
What is your words to describe?
Well, that's actually a good question, and you're going to struggle with that a little bit for some of you because you got to describe the smell. So smells, you can call it camphor smell. There's minty. There is wintergreen. There is kind of, and again, usually what happens is when you add whatever scent you're adding, you can kind of use that to describe the scent. So does anyone know the ingredient? And you can flip through the wet lab. We're almost to the wet lab. Look on the ingredient list there. What are we adding on your next prescription with the camphor menthol? You can see the camphor is the smelly thing. Now, some people love camphor, but some people hate camphor. So that's the smelly thing. You're adding what ingredient? What did I say? Or that's, you're going to, dropwise methyl salicylate. Does anyone know what methyl salicylate is? The same as oil of wintergreen. That's the oil of wintergreen. So you could call it, in knowing that, if you know that, then you can call it a wintergreen scent. Or you can call it minty. Or what I'd like for you to do is just, when you're all done, and try to describe it. You see what I'm saying? So use terms, though, that the best kind of describes that scent. That's the best I could, you could call it. Anyways, we'll try it with that. So you do need to try to come up with some sort of scent. Yep. Okay, let's make sure you understand. So overfill, you're talking about the amount of powder in here?
The amount of powder when you do what is
Excellent. Well, first of all, do you understand where the 24.4 came from in terms of excess to prepare? And we had that, Judy had that in her mortar. But we made more than the doctor permitted. So make sure you understand, what did the doctor authorize? 22 grams. If you filled it exactly where the doctor wrote, we could dispense 22 grams. So your QA, what needs to go to the patient is 22 grams plus or minus what we have as an allowable weighing error is 5%. So that answers your question. 5% is what we allow you to do for your weights. Okay? Awesome, guys. All right, so we're almost done with the dry lab, but we still got some boxes there. If you go back to the dry lab, especially on the left-hand side, there are some things we haven't completed yet that have to be completed. We finished the QA. Are we done with the QA? Very good. We did the Beyond Use Date. The reference for the Beyond Use Date for all semester is going to be USP 795. The only reason it wouldn't just be USP 795 is if your formula or your recipe is straight out of some journal. If it's the International Journal of Pharmaceutical Compounding and you're doing exactly what they had in their article, then you could reference that article. But you guys are extemporaneously compounding USP 795. What was the bottle we put it in? It's a shaker bottle, and it would probably be better to specify the size as a 2-ounce shaker bottle. And lastly, all semester under storage conditions, you will always indicate one of two things. It's one or the other. It's either room temperature or, what do you think? Refrigerated. Room temp or refrigerated. So for this powder, it's very important that it's room temperature. And it's because the other thing that needs to, that's not on my, it's not listed up there, go ahead and write down the other part to the storage needs to be in a tight container. Write down tight container. Can anyone tell me what the heck tight container is really supposed to mean? What tight? It's a shortened version of airtight. Why do we want an airtight container? What is in air that could cause problems with the powder over time? Humidity, moisture, absolutely. Which is why would storing this in a powder in a refrigerator, would it be bad because it got cold? It wouldn't be bad because it got cold, but what about the air quality in a refrigerator? It's very moist. It would be a terrible idea to do that. So again, that's why we kind of specified definitely room temperature on it. Okay? Any questions on that? All right, I think we've gotten most of that. Did you sign the bottom? Don't forget to sign the bottom of that form. You have to document who basically authorized, who's responsible for all this information being correct. So make sure that you sign the bottom. All right. Last thing that I skipped over there, and we'll be done, is auxiliary labels. I will tell you now, if you don't know what auxiliary labels we will be grading for on the exam, look on the QA sheet, which is usually page 2 of your packet. On page 2, you probably passed it. I go through the things that we look for. I will always list our grading auxiliary labels because some of them are fine, but there are some I will grade off on. For this dosage form, I'll be consistent. A topical dusting powder needs to have for external use only to ensure that it's used externally. And lastly, shake well. Can anyone tell me why you need to put a shake well label on this? Is it because the powder will separate like a suspension and you need to shake it up for the powder? No, what did we dispense it in? What kind of bottle? A shaker bottle. Why didn't we just dispense it in an open mouth container? It all come out, right? We want it to come out slowly, so the only way to activate the container is to do what with it? Shake it. So they're going to have to shake it well to make sure that the container dispenses the powder in the amounts that need to be dispensed so they can evenly and carefully apply to the correct area. So that's what's going on with that. Drug name. Part of the test on Avery dosage form would be how would you label this on a prescription label? Because you have to type prescription labels like any other drug for a compound. Compound names are more difficult for you guys to type. It is no different than a commercial product like this. Could you believe this? Rosuvastatin 20 milligram tablets. Is that a normal drug name on a label? It's the same thing for a compound. It's drug name, strength, and dosage form. It's the same, but they get a little bit crazy. So on this one, what we can kind of make things easier, would you agree we had 4 ingredients at the same strength? So let's just lump those together a little bit. So I said zinc oxide, comma talc, comma cornstarch, comma calcium carbonate, each 22.5%, comma, or with nystatin, 9984 units per gram. All of that was all my drugs and strengths, would you agree? And then end with the dosage form, which is a what? Topical powder. I will guarantee you someone in here will lose points because you will use the dosage form of powder. That's not acceptable because powders can be administered how? Both internally and externally. So you must describe your powder as a topical powder, in this case, if you're doing an external one. Okay? Big question that'll come up on your wet lab. Do you guys need to put methyl salicylate on the prescription label? We said you need drug name, strength, and dosage form. Methyl salicylate, is it an active ingredient? Is it providing something therapeutic to the product? Or is it more of a formulation ingredient? And by that I mean, is it something for a pleasant color, pleasant taste, or a pleasant scent? Would you agree? That's what I mean by formulation. If it's something for the formulation only, then it does not go on the patient's label. It's a part of your compounding record, but it would not go on the patient's label. So when you type your label for your wet lab, do not put methyl salicylate on it for the patient. It's not necessary. It's not an active ingredient. It absolutely needs to be very clearly documented in both your procedure and your compounding record, but not their label. Questions? And you'll get a chance to do all of this with your wet lab here in a second. All right, so let's go to the next page. Let's go to the wet lab. I want to get you out here making the stuff here. And again, I will remind you, we're going to go over a little bit of stuff to get you set, but we're not going to do the calculations. You're going to have to do the calculations. You're going to have to do all of this documentation yourself to get out of the lab. So let's just look at it kind of quickly. To read and to interpret it. For Richard Hansen, he wants camphor 1%, menthol 2.5%, and benzoic acid 5%. So we have 3 active ingredients there. Okay, along with some methyl salicylate, which we now know is added to make a favorable odor or scent. To those active ingredients, we're going to mix them with talc, and enough talc such that the final weight is how much? 15 grams. So you're going to QS up to a final weight of 15 grams. Subtract out all of your other active ingredients from the 15 grams, and that'll be your talc. You can ignore the weight of the methyl salicylate. We're not going to have to account for that weight because it's going to be a very small amount. It would not significantly alter the weight. So we can ignore the weight of the methyl salicylate. All right? What are we making? A topical dusting powder. If you look at the SIG, it says apply to the feet. So obviously we're doing something for a foot powder, probably something very likely for athlete's foot, if you look at the formulation record. So go down and let's fill out the formulation record. As you're doing that, I'll just help sure as you're doing a camphor and menthol. Have you ever heard of those before? They're used in, have you ever had like a menthol throat lozenge? Okay, they kind of numb, they cool, they kind of help sore areas. So think about really bad athlete's foot. What you're going to be doing with the camphor and the menthol is cooling and getting rid of some of the itching and some of the irritation. All right, so I hope it is kind of an analgesic. Benzoic acid is an antifungal, kind of analogous to what we did with the nystatin on the previous one. So does it make sense to have something for pain, itching, and irritation as well as an antifungal in a foot powder for athlete's foot? Then lastly, all of those active ingredients are going to be bulked up with the talc, which is again a good choice for an athlete's or a foot powder because what is talc good at? Absorbing fluid and keeping the skin dry, and that's a big problem obviously with athlete's foot. Okay, and the methyl salicylate again is there as a scenting agent. Hopefully you can get all of that stuff down and kind of see that. On the additional information, and again, you guys are going to do the calculations. Remind you, your calculations need to be based off of the preparation of 10% excess. All right? I will not remind you that on the exam, but for today, make sure you do all of your calculations based off of 10% excess. All right? Now, looking at this on my lecture, or the podcast that I'm sure you all really listen to, I did describe several different types of powders. And the way you formulate this, the way the procedure is the way it is, and this is important because it will mimic the kind of procedure you're going to have to do on the exam, depends on the ingredients. Those active ingredients, do any of those strike you as ingredients that might have issues like what I discussed? Are they efflorescent? Are any of those chemicals efflorescent? You know what the hell an efflorescent is. Remember when I know efflorescent? Those are powders that give off water of hydration. Why would that be a problem in a powder? Because if you mix them together and they give off water, what's going to happen to your dry powder? It's going to get all wet and clumpy and not be free-flowing. So we have to deal with that. Those are not efflorescent. Oh, what was the other one? There was a hydroscopic, and even deliquescent is an extreme of that. Those don't have any water in them, but what do? What does a hydroscopic powder do? Suck it out of the air, right? Any moisture in the air is going to get pulled into that powder and get wet and damp and have that same problem again. We don't have to worry about that. That leaves the fact that 2 of the ingredients on here are chemicals you should recognize that can cause a what kind of powder or have what kind of issue? A eutectic. They are going to form a eutectic, and we're going to have to deal with it. And the 2 are the camphor and the menthol in this prescription. So I'll remind you, how can you handle ingredients when you have multiple ingredients, some of which will form a eutectic? There's certainly more than one way. What I talked about in the lecture, and what we would want you to do in lab is to do this. Go ahead and start with the eutectic forming chemicals only, mix them together and form the what? Form the eutectic. And what is a eutectic? When 2 chemicals come together, lower each other's melting point, and instead of a powder, you get a what? A liquid. You will end up with powders coming together and forming a liquid. Do it. That's what you want to happen. In this method, form the eutectic. And if you put in other chemicals in the way, it'll prevent that from happening. So start with only the eutectic formers, mix them with vigorous energy and form the eutectic, and then add your other chemicals, and then use a powder sufficient volume that can absorb that liquid and basically pull that liquid apart into the powder and essentially handle it. Okay? So what would be a very highly absorptive powder to use with a eutectic type formulation? talc. Talc is awesome. That's what you're going to see. It does a really good job of adsorbing water. That's why we've kind of formulated it in both of these. Right? That's this idea of force and absorb. Now here's the deal. Write this down. This is a big deal. On the test, I expect that you would be able to identify those 4 chemicals. Any combination of those 4 chemicals in a powdered prescription, you should be able to identify those and realize, ooh, those were those eutectic formers. So my formulation should be to start with those, whatever combination of those 4 it is, make a eutectic from those, and then add other ingredients and then adsorb them into some bulk powder. Okay, that's the whole reason you're going to formulate yours today the way you are. Is to form the eutectic, add other ingredients, and then separate the liquid into the adsorbent powder. 2 today you're doing are camphor and menthol. The other expected that you would remember would be benzocaine and salicylic acid. Those very well could end up either on a wet lab or a dry lab part to the exam. Okay? Any questions on that? Looking at your wet lab thing in your packet, on the calculation section, I do guide you. I do suggest for you what calculations to do. I will not do that on the test, but today they're there. When you're done, when you go out there and do your own calculations, what I don't want you to do is make it wrong because you did the calculation wrong. So I have posted keys with these calculation answers that you can just check your answer to my answer before you go and make it. So please do that. Those keys are located not on the whiteboards, but in the middle areas where all the chemicals are by the sink. On the end by the sink, there are pieces of paper taped up that have my key for the calculations. Check your calculations not before you do them, but when? After. Do them yourself and then check to see. Any questions or problems, please ask Judy or I. We want to help you with this, but you need to now work on it. You're not going to know whether you need help unless you try it. Okay? So do and work on those calculations. Once you're done with that, then you're ready to go and weigh in everything else. One thing I will tell you about the process, remember, you must be wearing gloves and your white lab coat when you start to get your chemicals. Okay? So as soon as you start to go get chemicals, make sure you got gloves and white lab coat on. 1 chemical at a time. You've got 4 things you have to go get, but you go get 1 chemical, set it back down, go take your weigh boat, go get the next chemical, and so forth. So do 1 at a time. Make sure your weigh boats are labeled. It's real easy to get them confused. Okay? You do need to document steps within the procedure. So one thing I will tell you, you're going to make your eutectic, add the benzoic acid, and it's still liquidy. The step right before adding the talc is when you're going to add the methyl salicylate, because the methyl salicylate is a liquid. You can't add drops of liquid to a talcy powder, so don't do it. You got to do it before you add the talc. Here's a range. You don't have to write this in the margins or somewhere else. You're trying to get rid of the camphor smell. So take a big whiff of it and then add 2 drops. Start with 2 drops of the methyl salicylate and then sniff it again. If you're happy and you like it and it seems reasonable, you're done. Okay? And some people love camphor, so they're happy. So you can stop it too. Some people hate camphor. Go ahead and add some more drops because, again, the methyl salicylate is not Febreze. It won't make it go away. All right? It's going to give it more of a minty smell than just a camphory smell. So add until you're happy, until you get up to 8 drops. When you get 8 drops, beyond 8 drops, it don't never get no better. You're never going to like it. So just stop at 8 because it ain't getting better. All right? So somewhere between 2 and 8 drops to you're happy. What you do need to make sure is that you document in both the procedure and your compounding record how many drops you added. So that's an important part to the rest of that. Lastly, to get out of lab, you're going to have to make it, clean up everything, complete all the documentation. That includes all of the sections of the compounding record, the whole thing that we just did for the dry lab, so all of those sections have to be complete. You're going to bring either the hard copy or your electronic iPad with your final product. Come up, stand in line in front of the demonstration area. Judy and I will take you in groups, and we will do the checkout. We'll look through your final product. We'll look through your write-up to make sure it's complete and so forth. Then you're kind of good to go, but do this. Did you guys remember, and did any of you, I know at least one of you, tried the errors and omissions? The last of your packet, look at your packet right now, the last 2 pages are actually a prescription that has already been filled and compounded and documented by somebody else. That you're going to get that same exact kind of thing on the exam, and your job is to go through and circle and correct any mistakes. All right? So I have keys posted for the one that's in your packet on the whiteboards is where the key for the errors and omissions are. Whether you do that today before you leave or not, it is up to you. I would definitely take a picture of the key, do whatever you want, give the key. But I do need you. What's the problem? On the exam, be honest with you, and Judy will agree with this, most of you do pretty well in the wet lab. Most of you will do your prescription and make it just fine. You lose more points on the errors and omissions because some of you don't practice it as much or don't think about it as much, but it's a different skill. Because you're not doing it yourself, you're correcting the way somebody else did it. So you have to look at their procedure and identify what was wrong with what they did, not just the way you would do it yourself. So it takes some practice. It's a little bit different skill, and it is worth a third of the exam. So whether you do it today in lab or not, I don't care, but certainly get a picture of the key and certainly work on them. Be sure you're developing those skills. Judy and I are here to help you with that as well. So having said that, let's head on out there and get to work.